Welcome back, dear students. In this lesson, we are discussing about variables and data type, and as usual, we'll be looking at it for Solang Solidity while comparing it as well with vanilla Solidity or native Solidity on Ethereum. So let's check. The first one we'll look at is the variable, and when you talk about the variable, that's the particular value that help you to hold a value in a programming language. So if you want to say A equals to 20, so the variable is A that help you to hold the value of 20. So in Solang Solidity, just like you have it in the vanilla Solidity, you have different states like state variable and local variable. And what's the difference? When you declare a variable within the contract, you remember from the previous code, we have said it that almost all your code that will run for your contract will be inside this contract code. So usually the import or some in specific cases you have some code there, but most of your code that will be run will have to be within. So inside here, anything within this contract from the here to here, any variable you declare here is considered a state variable. So if we have this state variable, so we can have bool, for example. There are different types there, so let's use this as an example. We have a bool and is SPL token equals to true. So you can see it now. This as you see it here is a state variable, because any function, anything you have here, they can easily have access to the value of this variable. But it is a local variable when it is declared in a function. So for example, when you say function, returns bool, then inside here, for example, if we declare another bool, let's say this, so this is an example of a state, and this an example of a local variable. So what this tells you now is that this value that is here, you can easily access it in any function in here. But whatever variable you put in here, you cannot access it. Let's say there's another second function now, it can still access this, but the second function will not be able to access this except the value that has been returned. You understand? So that's the difference between state and local variable. It's applicable both in the vanilla Solidity and also in the Solang that we are focusing on. Now, just want to shift that in and we can now discuss about data type in Solang Solidity for Solana. So there are lots of things to learn, and I will just pinpoint some of them for you, and that's why I've also taken the time to always give you a kind of comparison table between them, so you can always go and check it below this lesson video, so you have it more detailed right there as you can see them. So what are the different data types that's available in Solidity, and which are available on Solang and which are not? So starting from the Boolean, that's what we have used here. The Boolean is all about yes or no, that's true or false. So it can either be false or true. So when you are dealing with variable or value that you want it to either be true or false, maybe do this when this is true or when it's false, then you use this type called the Boolean type, or we could short it to bool. That's when you use it, and we have seen this type of example. Yeah, this same thing I will be trying to show it to you under vanilla as well. You can see it's the same thing under vanilla Solidity. Like we'll be using remix. Here you can see also this is state variable, for example. And anything declared in a is a local variable. This was reassigned, it wasn't declared. So if it was declared, for you to declare a variable, you will need to, because Solidity is statically typed, which means you need to indicate what is it about, the type of the data type it is. So for this now, it is uint 256, which we still learn about this. So for example, if it had to be Boolean, that's why we need to first indicate it here that okay, this thing is Boolean, so whatever we assign to it can either be true or false. So we cannot make it this and then go ahead and try to add numbers. You can see it won't work, because we have already stated that this variable is a type of bool. It's a data type of bool, so it cannot hold any other one type. It cannot hold any other type. Let's check. Then we have integer types. So it can either be unsigned integer or signed integer. So this unsigned integer represented by uint, and signed integer represented by just int. So that was a typo here. I think I will correct that. So when you look at it, let's now look what's the difference. They have the same thing both on the Solang Solidity and vanilla, but the only major difference you can see while you are developing is that this based on Solana is maxed at 64, but on Ethereum, the normal EVM, you can currently have up to 256 integer or uint. So that's why you will notice when this was declared here, it says using uint 256 numbers. So this same one, if I want to declare it here inside Solidity, not that I can't use this, but it will be too costly, because it will have to break it instead of your transaction or your value being processed like one transaction. It will be broken down into more multiples, which each will cost you. So why do that if you can just put it at 64? You can see it, and a lot of these already work well with each number you will likely be dealing with. So that's why it is more recommended in Solang Solidity to use uint 64 compared to using the 56 in EVM. So as you can see it here, then you can see these are examples. You see this was using 256. Then we have fixed length byte arrays. This can be represented as string byte 4 equals to A, B, C, D, hexadecimal, which A is 41, B is 42, C, and then like that, or hexadecimal value, which OX41. This hexadecimal value, we also talk about address. You understand how it is used in EVM. So this as well can be from byte 1 to byte 32, and it only allows using arithmetic operators. So whenever you are using byte, you can use also arithmetic operators with it, and this is an example of it being used for hash. Then the fourth one talk about address type. When you look at both, is a data type that hold the like a pointer to your account, maybe on EVM or something. Your account hold your token, Ethereum or Solana or any other ERC20 token or SPL token. So the same, you have it here, and there are some basic differences between them. For example, on Solana, the address length is about 32 bytes, whereas on EVM it is 20 bytes, and you can't do arithmetic operation on address. For example, this will be an example of an address on Solana. Yeah, see, so it's different from usually Ethereum that you have OX, because Ethereum usually is written in hexadecimal value. So you can see the differences there. Then Solana address is written in base 58 as we have it here, while EVM address is written in hexadecimal format, value format. So you can see it OX, E94 and things like that. Then 3 does not require conformity to Ep11 checksum. After the Ep11 checksum was approved, that's Ethereum improvement proposal. That's, if you are not used to the Ethereum ecosystem, is a proposal that the Ethereum developers propose, okay, we need these features to be changed, and once there's consensus voting here and there and that thing has been agreed and passed, then it will be implemented and referred to as EIP, then depending on the number of that proposal. So after that, this becomes compulsory for vanilla Solidity compiler to check if the address conform to that Ep11 checksum, but that is not applicable when we are working on Solidity, Solang Solidity. So you can see, then it accepts comparison operator like equals to, you can compare this address, is it equivalent to the owner's address or the deployer address on Ethereum. That could be like message.sender and things like that. So, but you cannot say this address plus this address. It doesn't work like that. So it has limit to the kind of arithmetic operation or operators you can use with it. So let's move on. Then address need to be represented as a string literal with the keyword address, as you can see it here. Why over here you don't need to put it. So you can see the example address wallet, because to address this, the address wallet, then you have the hexadecimal value. The next one you talk about enums. Enums is a user-defined data type that consists of a set of named values. This named value make your code more descriptive and easier to understand. For example, instead of using integer to represent the days of the week, you can create an enum like this. So for example, instead of you taking this and saying Monday, Tuesday, Wednesday, and holding each as individual variable, you can put, it's like putting multiple variable in a place, but each also tagged to a number. So you see it now. If we want to create this, we have enum, then you use the keyword enum, as you can see it there. Enum, come in. State, it has no field. Created. So you can see it now. So instead, we can as well, for example, make it, okay, Sunday starts the week, then Monday, and so on and so forth. Here we can see that we have our enum now, and as much as you want it, it keep on going. So each of these is represented is the same, like 0, 1, 2. So it's like an index of an array. So if you want to refer to this, it's index 0, index 1, index 2. I just use that as an example. So that's what you use an enum for. The next is struct. So struct in Solidity serve as a powerful way to group related variables together under a single name. Think of a struct as a custom data type that can hold multiple properties, each of a different type. This feature is particularly useful for organizing data and making your code more readable and maintainable. So if you can see, compared to enum that just have a pair, Monday this, when you are dealing with struct, it's like key and value pair. Let's quickly do that. You start with the keyword struct, then whatever that is, you can make it. But since we are using, let's try and use week. So inside the week now, we want to have Monday, Monday, or let's say Sunday. So Sunday will be string. You can see Monday. Then we have it like that. Maybe string again, Tuesday. Then you can also have other ones. We've learned about the integer or signed or unsigned integer, and you can continue to add as many and refer to them. So what this is saying is a data type of string, which you will still learn, and we have learned about uint and integer, which can be signed and unsigned integer. So as you can see this amount there, and one of the basic difference is this unsigned integer can only hold positive number. That's why you see that most usually use unsigned. You see, so you only use int when you are expecting that the number also can go down to minus, so negative. So it can include minus, for example, 1, then plus 0, 1, 2, 3, 4 and more, then minus 1, minus 10 and things like that. But if it is unsigned, it only take the positive. And for example, most times you are dealing with money and value. So usually, for example, you are dealing with a balance. You usually will not like the balance to go down to minus 0. It can go to 0, but not minus. That can break the smart contract. So that's why you will notice most times, most smart contracts or program on Solana uses uint, not int. So that's very essential to keep in mind. So that's basically what struct is, and then you can make use of them. Like I've said, I've also included resources, which you can decide to go through the official doc and other resources I find helpful for me, even while I was preparing this material, which you yourself can find time to read through, and it will be so helpful doing so. Now let's talk about arrays. So arrays are, you have multiple numbers or string or a lot of other things together, and you fix them, each of them. You can add, you can pop, just if you have worked with things like JavaScript and things like that. Same in both the native or vanilla Solidity and also in Solang. So it's an item in index also starts from 0, similar to what I explained in the enum. So if you want to add or write an array, so how do you do that? Remember I said that's why you see more preferably using uint, because it's only positive, you can't use negative number, and you should be careful using int except you are sure your program handles negative number. If not, you don't want to use it to balance, because it means people with minus can still transfer token, for example, which you don't want that. You want, once their balance is 0, then it should be error. It should show error and cancel their transaction, that they don't have enough value or something. So here now, if we have this and you want to write the array, you need this, and then you can declare what you want, like we have prime numbers, then the same you will have it here. So it can be 2, 3, 5, 7, 11, 13 and more. So this, we have two types. You can see one has fixed length and another called dynamic length. So the basic difference between them is in the fixed case, you have to pre-state what's the precise length. So when you precisely know the length ahead of time, but when you are programming and maybe users may even add more to the array, remove or things like that, you may not actually know how long the array will eventually become. So in such a case, dynamic, and the major difference is you don't specify inside the array icon, this close box. But if it is fixed, you have to specify. For example, let's say you have to put in 5 or 6, you understand? So if we say 5 here, then it means this can't be more than 5. If you put 6. So it can be more than 6. You put 10, can be. But if you are not sure if it will be just, then you leave it empty. So that's dynamic. Then this can continue to go till as much as is manageable by your smart contract. So those are the major one you have there. But this support for push and pop method are in test more with Solang, because for example, if you want to add to this array now, these are the method you use. You push to it or you pop. That means you remove from this list. So it's just like a list. You have them. You can pop out of it or you can push to add new one after this. So that's just the major difference between this dynamic and so over this can be like 6. And as usual, if you want to refer to them, this is 0, 1 by their index. So this is 0, 1, 2, 3, 4, 5. So you don't count it 1, 2, 3, 4, 5, 6. This would have been 6, but by their index, this is just 5 because it's starting from 0. Then the next one, let's look at string. So have I used string here? Yeah, I indicated there about string. So how do you declare string in Solang, Solidity? Then you have, remember you need to indicate because Solidity is statically typed. So string, then maybe my name, now good, you can see that this is giving you unrecognized token and things like that. So different from what we have been dealing with before, that we just use the uint and declare the number and things like that. Over here, when you are dealing with string, you need to put it inside a quote. Do you see it now? So this, and you can, this used to overshadow each other, so let's make this 2. Yeah. So you can see it now, string, the variable value name, and then the value should be in a string. It can be one quote as well. It will still work. Sorry. So either it's double quote or single quote, it will still work, as you can see it here. So you see the string name, and you can have it there. Then the next one is mapping. Just remember, whenever it's string, it has to be in quotes. If it's not in quotes, you will get error. Then the next one we talk about is mapping. So what's mapping is it's how, for example, let's see this, marking key type into value. For example, if you are creating a token on EVM, you need something to hold this value for you. If you come here, you want to have a mapping. Understand? Because you want to mark the value type. So this value type, in this case, so here now in the mapping, when you look at it, based on this, you can have address to uint. For example, let me try and use this as an example. So you can say, let me explain what happened here now. So for example, if you have that token, you have the token this is trying to map. If somebody is able to have your address, they can know the amount you have. So that is what this is. It maps it to each other that, okay, the owner of this address A owns 10 tokens. The owner of address B owed 20 tokens. So, and then you state the name of what it is. This is actually holding a balance. So you can see it now. So it's, let's say, token balance or whatever it can be, anything is holding there. So that's what you use mapping for. But presently now there seems to be more work to make it even work much better with Solang Solidity. Then the next one is contract type, which an instance of another contract can be called within a contract and its function accessed simply by using the new keyword. So you can as well check the example like I told you. I won't go through everything, but at least I just point them to you and they are already there for you. I've explained it with examples, so you can always go back to the table anytime you need them, and they are also the reference to the official doc to support. So you have the function type as well that you can use. So for example, now when you are writing a function, you can declare it view or pure. So what does this and what's the difference between them? So for function types, you can have things like this. You see this function is declared view or pure. So there are about two variations of that, which is like you specify whether the function is pure or view or has default mutability. That is, can modify state, but it's not payable. Now, normal when you declare a function like you have here now, if I didn't declare it view, then there's something we call the setter function and the getter function. So this setter function, for example, has the ability to change something, the state of your smart contract. So maybe I want to change this number value from 5 to 10 and things like that. But if you put it as view, then it means this doesn't change anything in the state of the smart contract. It only wants to view. So in this case now, you won't have something like this. You just want to view. You can see it. So you are just returning the value. Whatever the value is, you are just returning. You are not doing anything. You are not changing it. You are not adjusting. You are not increasing. You are not decreasing. So that's when you use the view. But still, it's interacting with a state variable. You can see it is trying to check the value inside this variable. But if you have a type of function that doesn't interact with anything outside, so in this case, let's say it's just this. So you see that this is within this function and it's not there. You see it now, it's just within the function, it's not interacting with anything outside there. Then you can use pure. You see it, you can use pure because it's just within itself. It's not even interacting with any of these state variables that you have here at all. So this app, the Solana, for example, our runtime environment to do some things in parallel. For example, if it sees that these are just pure view function, then it can run multiple of those functions at the same time because it knows that they do not change anything in the smart contract. But if it is not, then it might not be, because running them parallel may cause issues. Because if one changes and the second one need to also use the new value, then if the second has run before the first or at the same time, there could be issue with the value. So that's how the function type work, and you can see them. Storage variable, but internal function type cannot be used in public function parameter or return types. Then assignment, when assigning to an external function type, you must specify both the contract and the function. So that's when you are using it outside of the particular smart contract itself, because in native or vanilla Solidity we have inheritance and things. That's when your smart contract now, another smart contract inherit it and then make use of some of its features. So we still learn some more things relating to that as well. Then we have storage reference. As you can see, variable parameters and return type can be a reference to a storage variable simply by adding a keyword storage to them. So when you talk about things like this, in Solidity, there are different memory. You have like storage, which is like the permanent. Anything you like store here is stored in the storage of the smart contract itself. So it's stored on chain, stored like permanent there when you talk about like RAM or ROM. But we also have other ones like memory and things like that is just temporal. You know, when you have a ROM, it's permanent storage, but when you store on RAM, it's just the current session, and when you off your system, for example, that storage, whatever is there, is gone. But as long as the system is on in that session, you can use whatever value is stored in the RAM for any other application you are using it for. And the same on your normal vanilla Solidity. So then we have the user defined types. The user have the opportunity to define specific types. So we have some key points you can as well read. And also there's a kind of FAQ here looking at difference between function feasibility and function types. So we've discussed about this pure, but there's other ones like this public. So we'll still get to them, but you need to know they are different. This one is function types, not visibility. This one determines how the function will be visible, either it is within this contract alone, outside of it, both inherited or not. But this is just telling us, is this function actually meant to change the state of the storage or whatever in this contract, or is just viewing? And you know, when you view, usually you don't spend. But when you are changing things, then it costs a lot to do depending on the exact thing you are doing. So that's why it's so essential to understand the difference between them, so it can be confusing. Was this public, was this pure or view? So you still learn more about this later in other aspects of this course, but just keep in mind there's difference between function visibility and function type. So function type is a type of data type that shows if this is pure or view. So that's it for this lesson. I hope you've learned. Don't forget, if you get stuck, head straight to the Discord community to get support, and I will be there to support you or any of the team as well. So, or even the community can as well provide support. So that's it. Check the table anytime. These are not things you can keep in your head. They are just there to actually don't be much bothered about this thing. Just have idea, because you can't keep everything. But once you start programming with real project, this thing keep getting stuck well into your memory and you remember them. So that's why the course is also included with a practical ERC project that will be converting to SPL token, so that you can see some of these things practically in real world use cases. So that's it. I will see you in the next lesson. Keep the program sweet and high and alive. I am Solomon Foske. Peace and bye.